Okay, this is the last section in chapter 7, 7.6 on natural logarithms. The main thing to remember in this section is that all the properties of logarithms we have learned apply to natural logarithms. Okay, the only difference is that the base is e for natural logarithms, where in all the other logarithms we've been looking at, we have different bases, and we've been using the common logarithm of base 10 a lot. Okay, but in this case, all the properties we have learned still apply. All right, so let's get started. Oh, and as always, remember, pause it whenever you feel like you need to. Try the problems first before actually watching the way that I do it or the correct solution. Here we go. Okay, so this first few problems says, write each expression as a single logarithm. The first expression is simplified for you. So number one, they already did some of the work for me. They took the 3 and the 4 and they put it together, and they're multiplying them times each other. Okay, which is what you're supposed to do because there's an addition sign right there, okay, which turns into product. So it's basically ln of 3 times 4, which will be ln of, oh, wrong color, which will be ln of 12. And that's your final answer. Number 2, 3 times ln of x minus ln of 5. It's already started for us again. They already took that 3 that is a coefficient and they wrote it up here as a exponent. Okay, so ln of x cubed equals minus ln of 5. I see subtraction, so we're going to use the quotient property. I'm going to write ln, once again wrong color, I'm going to write ln of x cubed over 5. And there's your final answer. And number 3, ln of 3x plus ln of 4 minus ln of 8. I'm going to do the stuff in parentheses first. Since they are both all natural logs, the base is e, I can put them together using the product property. So that first one is going to be ln of 3x times 4, which is 12x, minus ln of 8. Now I'm going to use the quotient property, subtraction. So now I need to divide. So I'm going to get ln of 12x over 8. Simplify it as much as you can. So my final result, 12 and 8 can both be divided by 4, right? So it's ln of 3x over 2. And that is your final result. Please don't write ln of 3x over ln of 2, right? The point is to put them together as one single logarithm. Okay, now using natural logarithms and e, we can solve equations using the same properties that we've learned before for logarithms. So let's look at number 4. ln of 3x plus 1 equals 4. So it's already started for us. What they did is they turned it into exponential form. The base is e, so they wrote e to the 4th, right here, e to the 4th, because the base that's supposed to be here is e to the 4th power. E to the 4th equals 3x plus 1. They multiply, they subtracted 1, so they get 3x equals e to the 4th minus 1. This 1 came over to this side. And then using a calculator, e to the 4th minus 1 is 53.6. And then finally 53.6. In order to solve this, all you got to do is divide by 3. So 53.6 divided by 3, again on the calculator, gives you 17.9. And that's the final answer. 5. Steps are very, very similar, basically the same. ln of y minus 2 equals 3. Turn it into exponential form. The base is e. So e to the 3rd power, remember the base here that we don't write is e because it's a natural log. If it said the word log, log, then you would use the base 10. E to the 3rd power equals y minus 2. So what you do now is in a calculator, well, first let's add 2 actually. Let's add 2 and then we could just do everything on the calculator. Y equals e cubed plus 2. Put that in the calculator. E cubed, your e button is right there on the calculator next to the ln, on top of the ln button. So you get y equals 22.1. And that's your final answer. And number 6, 3 ln of 2x equals 3. We're going to try to use the same steps that we've been using, except for this one, there's a 3 in front of ln. We don't want that. Remember, we want the logarithm or the natural logarithm to be just a coefficient 1. which we don't write. So what we're going to do first is take that 3 and write it on top, like this, ln of 2x. Oh no, you know what? Instead of writing that 3 as an exponent, I think the easier way is to just divide it out. Let's do that instead, right? Before we take a longer way. The easier way would just be to divide the 3. And it makes my job so much easier. When we divide by 3, we get ln of 2x equals 1. Makes my job so much easier now. Turn it into exponential form. The base is e to the 1 power equals 2x. And then all you got to do is divide by 2 to find your final answer. So your final answer, I'm going to write it up here in blue so it stands out. X equals e to the 1 divided by 2. Just punch that into your calculator. You don't have to do e to the 1. It's just e divided by 2, which is approximately 1.4. There's your final answer right there. Okay, so in the last few problems, what we did is we solved logarithmic equations by using the base e, okay, because the equations happen to be ln, natural logarithms. In this next few problems, what we're going to do is solve equations that have an exponent of x and the base is e by using natural logarithms. Okay, so here we go. Let's start with number 9. It says 2 times e to the 4x power minus 4 equals 10. First thing I'm going to do is kick out that 4, right? We're going to add 4 to both sides to make it simpler. So I get 2 e to the 4x power equals 14. Then I'm going to divide by 2 to get rid of that. And I get e to the 4x power equals 7. And now from this point is where I'm going to take the natural log of both sides. You're not going to take a logarithm with base 10 like we've been doing before. You're going to take a natural logarithm because since the base is e, it's going to cancel out. So I'm going to take ln of e to the 4x equals ln of 7. And now the next step would be to take that 4x and bring it to the front. Okay, take this 4x and turn it into a coefficient over here. So what I get is 4x ln of e equals ln of 7. And now ln of e can go away because ln of e is 1. Since the base is e and the argument is e, it cancels out. So it's 4x equals ln of 7. And now your last step is just simply to divide by 4. So x equals ln of 7 over 4. Just do it on a calculator and you're going to get approximately 0.4. It says round to the nearest thousandth up here, to the nearest thousandth. So what we're going to do is leave it to 3 decimal places, 486. That's your final answer. Alright, now let me show you something here that you can do to make your process a little bit easier. Okay, at this point right here, e to the 4x equals 7. You're going to take the ln of both sides. What you can do when you take that step is basically cancel the e and write 4x equals ln of 7. Go straight to this step. Because when you take the ln of e, it just cancels out, leaving you with just the 4x. You're going to see that as I do number 10. Watch what happens. I can just skip that step. I can jump from here straight to this step right here. 4x equals ln of 7 by taking the ln of both sides, the natural log of both sides. Okay, let's move on to number 10. Okay, number 10, e to the x over 2 power plus 6 equals 12. First thing I'm going to do, like before, is kick out that 6. So I'm going to subtract 6 from both sides. So I get e to the x over 2 equals 6. Right? I just subtracted 6. Now I can take the ln of both sides, and you can take that step that I showed you, right? ln of e to the x over 2 becomes just x over 2. And on the right side, you have to write ln of 6, right? So I skipped that step that I told you. I took the ln of both sides, but on the left side, what ends up happening is the ln and e cancel out, leaving you with just x over 2. And now to solve, just multiply by 2. So your answer is x equals 2 ln of 6. Use a calculator, and 2 times ln of 6 is going to be 3.584. to the thousandths place. Again, that's an approximation. Alright, now let's look at number 11. E to the x minus 2 equals 28. It's already ready. There is nothing next to the e, right? The power is x minus 2, but that doesn't make a difference. The steps are going to be the same. So I'm going to go ahead and just take the ln of both sides. When you take the ln of the left side, remember ln and e are going to cancel out, leaving you with just x minus 2. On the right side, you're going to get ln of 28. And then all you got to do is add 2. So x equals ln of 28 plus 2. Calculator tells me that x equals ln of 28 is 3.332. We add 2, so x equals 5.332. And that's your final answer on that one. Alright, let's do a few more now. Number 12, e to the x over 4 minus 3 equals 21. Again, first thing is to kick out that 3, so I'm going to add it to both sides. I get e to the x over 4 equals 24. Take the ln of both sides. On the left side, when I take the ln of e, cancels out, leaving you with x over 4 equals ln of 24. And now to solve it, multiply by 4. So x equals 4 times ln of 24. And punch that into a calculator. 4 times ln of 24 is 3 times 4 is 12.712. That's what the calculator says. Alright, number 13, same idea. E to the x plus 2 plus 4 equals 17. First thing I'm going to do is get rid of the 4, right? Subtract 4 in this case. So what I do is I'm going to get e to the x plus 2 equals 17 minus 4, which is 13. Now take the ln, take the natural log of both sides. And once again, ln of e cancels out, leaving you with just x plus 2 equals ln of 13. And then subtract 2. So x equals ln of 13 minus 2. Punch that into a calculator to get your final answer. Ln of 13, take away 2, you're going to get 0.565. 0.565. That's your final answer there. Alright, and number 14, 3 times e to the x over 2 minus 5 equals 19. Again, same first step. I need to kick out that 5, so I'm going to add it. 3e to the x over 2 equals 19 plus 5 is 24. Then I'm going to get rid of the 3 by dividing it. Right, divide the 3. So e to the x over 2 equals 8. And now I take the natural log of both sides. On the left side, when I take the natural log of e, it cancels out, leaving you with x over 2 equals ln of 8. Alright? Don't get confused at this step. All I'm doing is taking the natural log of both sides. But what happens on the left side is that the e and the natural log cancel out, leaving you with just x over 2. On the right side, it's ln of 8. And then finally, multiply times 2, so you get x equals 2 times ln of 8. 2 times ln of 8, punch that into a calculator, and you get x equals approximately 4.159. 3 decimal places in these, right? 3.15. 4.159, sorry. That's your final answer on that one. Alright, number 15, this is the last one we're going to do in this section. It says, explain the steps you would follow to solve the equation 4 times e to the 3x plus 6 equals 30. And then what is the answer? So this is one of those explanation problems. Very, very important, especially with the Common Core type questions and the Common Core questions that you get on your tests. Okay. So explain the steps you would follow. 4 times e to the 3x plus 6. Step 1, subtract 6. Let's list them. Let's do it in black. Step 1, subtract 6 from both sides, right? Step 2, now when you subtract 6, you still have a 4 in front, so divide by 4. Now after you subtract 6 and you divide by 4, it looks like you'll have e to the 3x equals 30 minus 6 is 24, divided by 4 is 6. E to the 3x equals 6. Okay, picture this in your head. Now what you do is take the natural log of both sides. Once you see that you took the natural log of both sides, natural log and e will cancel out. On the left side, all you will have left is 3x. So to get rid of the 3, the final step is to divide by 3 on both sides. Everything, all 4 of these steps are on both sides. So what is the answer? Let's figure it out. Let's see what we get. Let me erase all this here. The answer would be, if we follow the 4 steps that we just wrote, subtract 6, so we get 4 e to the 3x equals 30 minus 6, 24. Step 2 says divide by 4, so if we divide by 4, e to the 3x equals 6. Step 3 says take the natural log of both sides. When you take the natural log of the left side, ln and e cancel out, so you'll just have 3x equals ln of 6. And then finally, step 4 says to divide by 3. And so your final answer will be approximately 0.597. That's what the calculator says.